It's a pleasure to be here today to tell you a little bit about the research that I've been doing at Rothamsted for what actually seems like a very long time, because it is quite a long time, and that's the nature of doing fundamental research. It sort of seems to stretch out over a long time period. I was going to say, speaking of long time periods, it's also nice for me to be involved in something that Nottingham is involved in, because I did my undergraduate studies at Sutton Bonington about 700 or 800 years ago, and as Jerry here can testify, because he taught me. So, one of my successes. Exactly. Yes, he always. Yeah. Yes, he taught me all I know. So that on that bombshell. So so I'm going to tell you about the research that we've been doing at Rothamsted, as I say, and well, I like to think of it as it's a research project, and it's quite a fundamental research project, but I'm not going to tell you about the nuts and bolts of how we did it. You'll be relieved to know. And I'm going to tell you more about the context of why we did it, where we've got to, and actually what I think is interesting now is that it's almost like a research project that's come to the point of it's finished being a research project and now has to move into the development phase. So for us, it's quite an exciting time, but it's also an area that we sort of move out of our comfort zone because we're a research institute. We're not a development, a commercialization organization. So maybe that's something you can help me with and give me some pointers. So I always put this slide up. I'm just wondering which one of these is the pointer or the one that turns it off. So I only put this up because whenever I'm talking about my research, which is biotechnological, people quite often assume that Rothamsted Research is a biotechnological or a spin-out company. Of course it's not. It's just Rothamsted Experimental Station after some sort of funky rebrand 10 years ago, which makes us sound like a spin-out company. But we are, in fact, the oldest agricultural research station in the world, and we're about, I don't know, I guess 20 miles south of where we are now. So it's, we're in the heart of the arable agriculture area. So that's a little bit depressing. So it doesn't quite fit on the screen. There's a plethora of things here that it fits on this screen, but it doesn't fit on that screen. Okay, so anyway, so the reason what I'm going to tell you about is the work that we've been doing on omega-3 long-chain polyunsaturated fatty acids, which the shorthand for which is fish oils. And fish oils are important for a whole range of reasons, of which some are quite literally partially outlined on this slide. In that so the reason that we're interested in is that omega-3 fish oils are health protective. They're an important part of our diet, and so they're really they're compounds that you see in lots of food ingredients that are available in the supermarkets. And they're also, as I'll tell you in a moment, ingredients in animal feeds. Now the problem is that the omega-3s that we all consume, and we have to consume because they're an essential component of our diet, are basically a diminishing natural resource. So the omega-3s, these fish oils from the oceans, are not sourced in a sustainable fashion, which this is a slightly controversial statement. When I talk about not sourced in a sustainable fashion, if there's anybody usually from the fishing industry, they go completely ape when I make that statement. They prefer to use the phrase that I think is being sourced sustainably at a maximum level or something like that, which is a euphemism for taking as much as you can without getting sort of shouted at. But anyway, I think we'd all agree that there is problems with overfishing, and fish stocks is a big issue. There's also and that's why if you're omega-3s, if you say that omega-3s are all coming out of the oceans, then so we need to think about how we source them. The marine environment, I'm sure lots of people are also aware, the marine environment, so where fish oils obviously come from, suffers from pollution which accumulates in the food web. So there's problems with things like heavy metals like mercuries and dioxins and other unpleasant things actually accumulating in these food webs, which then get accumulated into fish and fish oils. So there's a problem with food safety in terms of the ultimate end product can end up being contaminated. That caused problems with supply chains and the security of sustainability. And so also the omega-3 long-chain polyunsaturated fatty acids that we find in fish oils are absolutely not the same thing as the omega-3 fatty acids you find in plant oils. There's some sort of I would argue, almost what's the word I'm going to look for without being too controversial? I would say not, well, there's lots of things you see in the supermarket that are labeled as saying high in omega-3 fatty acids. And usually, in a lot of cases, those omega-3 fatty acids are derived from vegetable oil. So they're just derived from linseed or flax oil or something like that. Unfortunately, linseed and flax oil it's rich in omega-3 fatty acids. It's not rich in these particular type of omega-3 fatty acids. And more importantly, and this is the bit that I think is really sort of really cheeky, those plant omega-3 fatty acids do not give you any health benefits. So anybody who tells you you can get health benefits from eating flaxseed or linseed is talking rubbish. You don't get the health benefits from eating those fatty acids. You only get them from eating fish oils. I obviously sound like I'm trying to sell you something, and later on I'll give you an opportunity to purchase my fish oils in the foyer. No, maybe next year. So this is all context for what I think. These are the things that I get quite obviously aerated about in terms of the whole background for what we're doing. So there's an issue of sustainability of taking stuff out of the ocean. There's an issue of pollution. Plant oils can't substitute for fish oils. So therefore, and as I've already alluded to, the omega-3s have a clearly proven health protective role. We need an alternative source of these fatty acids. I'll show you in a moment what the particular health protective roles are. And we believe that transgenic plants engineered to accumulate omega-3 fatty acids represents a viable alternative system. And you could have a bit at the bottom here that says discuss, because obviously this is GM and this is transgenic. So there's a whole, this is something we can talk about later on, because I think it's really an interesting whole thing to think about. Now, the reason that we use transgenic plants is not just because we perversely want to do it, it's because there is no other way of doing it, in my opinion. There is no natural plant species that makes these omega-3 long-chain polyunsaturated fatty acids. There's no sort of obscure wild relative living up a mountain in Azerbaijan that you can then cross with your oilseed plants to bring that trait in. It does not exist in terrestrial angiosperm plants. They just don't make these fatty acids. So I can't think of any other way that you could get plants to make these fatty acids other than through transgenesis. So the health protective thing that's really important about these fatty acids is there's a huge amount of evidence. So unlike lots and lots of nutrients that you find slapped into foods as being good for you, as sort of just additives, omega-3 fatty acids from fish oils have a very proven role in reduction of risk of cardiovascular disease. So they can really reduce your risk of cardiovascular disease. And lots of health agencies recommend that we should have a moderate consumption of omega-3 long-chain PUFAs, say something like between 0.5 grams and 2 grams a day, but they probably just mean 2 or 3 times a week. So the dietary recommendation for eating these fatty acids is really moderate. So you could get this by, ideally you should just have 2 or 3 portions of oily fish a week, but most people don't. A lot of people don't like eating fish. So if there was a way that you could supplement the diet by, for example, margarines that were enriched in these fatty acids, that would be great. And it could reduce this sort of depressing progression. And I always stand when I suck my stomach in when I show this thing, especially if I'm standing side on to the audience, this is the sort of Western diet now that is, and this is all very funny, but the problem is it actually represents a massive burden on our health systems, and it's a public health crisis. So, the figures for 2030 in the UK is that 30% of the adult population will have type 2 diabetes. And you think, and the burden on the NHS is going to be is grim. You think the NHS, God bless it, is creaking at the seams now. So if you imagine that a situation where a third of the population has diabetes, it's going to be pretty grim. So better nutrition, is a pretty simple way of improving people's health, and also making their lives a lot less miserable. So that's one of the drivers, again, for why we're interested in producing a sustainable source of fish oils, because fish oils, as I said, omega-3 long-chain PUFAs have this health protective role, but there's not a sustainable source available at the moment because we're overfishing, and then you know, there's the problems in the marine environment. So this is just to influence. So I just want to we'll just skip through this very quickly. But this is just the different types of fatty acids, and these are these omega-3 long-chain polyunsaturated fatty acids that you find in all these different fish species. So anchovies, whatever you like. So they're present, and the numbers just mean the percentages. And this is just to emphasize what I said earlier, that they just don't exist in any vegetable oil. So this is linseed, which is always trotted out as being an omega-3 rich seed oil. It is omega-3 rich. It contains this omega-3 fatty acid, alpha-linolenic acid, but it does not contain any of these fish oil type omega-3 long-chain polyunsaturated fatty acids. So if I sound slightly ratty about this, I've had hundreds and hundreds of people, you know, when I've talked about this, ask me a question, say, don't you know linseed is full of omega-3 fatty acids, assuming that I'm going to say, like, oh, damn, I must have overlooked this fact, you know, and my entire research career is based on the fact that I didn't check it on Wikipedia or something. I mean, you know, or my idiot lecturer at Sutton Bonington never told me this fact. But it turns out that I was right. Yeah, I knew you'd take credit for it. So this is the, you know, actually, so the omega-3 food web is quite interesting because although we call them fish oils, they're not actually made by fish. You know, fish and humans are the same. They have the same, they're vertebrates, and they have very limited ability to synthesize omega-3 long-chain polyunsaturated fatty acids, which is why they're important for us. We have to get them in our diet because we can't make them. But the things that make them are the marine microbes, so little plankton, algae, diatoms, little unicellular organisms that are absolutely like bobbing around in a soup in the marine environment. They're the organisms that are making these omega-3 long-chain fatty acids. And if you're a fish in the ocean, then you just, you know, you're in this food web that's full of these healthy fatty acids, and you just accumulate them naturally in your diet. But the problem is, so this is another confounding problem with sustainable sourcing of fish oils, is that most, for example, a huge amount of fish that's in the supermarket shelves these days is produced by aquaculture. It's not by capture fisheries. It's by fish farming. And so, for example, and when fish are raised in cages, you have to feed them, and you have to feed them in a way that is that they get the omega-3 fatty acids into their diet, and obviously that can't be done in the same way as if they were out in the ocean. So this. Fish farming is, you know, I think it's a very interesting, progressive modern industry, but they're still struggling with this statistic, which I think is sort of frightening from a sustainability point of view, is that for salmon farming, the fish in, fish out ratio is 4-to-1. So you take 4 fish in and you get 1 out. Now, from a sustainability perspective, that's quite problematic, I think. Now, I'm not saying these are 4 salmon to get 4 salmon out. These are 4, so it's 4 kilos, for example, of trash species like sand eel or something like that. But it's still you're still putting a lot more in to get something out. And the reason we're putting the fish in is because you have to feed the salmon fish meal and fish oil, and because those are rich in the omega-3 long-chain polyunsaturated fatty acids. So there is big pressure on aquaculture, on fish farming, to try and find an alternative source of fish oil and fish meal. So this, you know, and so aquaculture is very interested in alternative sources of fish oil and fish meal. So we're talking with aquaculture as a possibility, because 80% of the fish oil that comes out of the ocean each year goes to aquaculture. 80%. It's a huge amount goes into aquaculture. It's a sort of really booming and voracious, literally, industry that is consuming an enormous amount of fish oil. So I'm going to tell you a little bit. That bit at the top here says the vision. GM camelina is a new omega-3 crop. So I'm just going to show you what we've done to try and I've given you my sort of slightly demented pitch on why I think what we're doing is important, and I'm going to now tell you literally. I've got to stop saying literally, how we've done it. So camelina is an oilseed crop. It's grown in North America a lot as a biofuel crop, but we like it. It's a cousin of oilseed rape. But in Europe, it's also used as a food ingredient. So it's already established as a food ingredient in Europe, especially in Eastern Europe. So how would you go about trying to make says how to make an omega-3 long-chain polyunsaturated fatty acid in a heterologous host. I already told you that the actual organisms that mainly make, that actually are the primary producers of omega-3 fatty acids are marine microbes. So these are tiny little things. These are the algae and diatoms that are beautiful to look at under the microscope, but they're the primary producers of omega-3 fatty acids. So if you wanted to try and make an oilseed plant that can make the fatty acids you find in these diatoms and these microalgae, you have to find the genes, take the genes for this pathway out of the algae and put them in the plants. And that's the sort of trivial idea that we had 15 years ago, and the fact that I'm still here talking about it tells you it wasn't that trivial and it was quite hard to do. And the reason it was quite hard to do, and we don't need to dwell on this is the biosynthetic pathway, which all this tells you is, you look at this and you think this has got more arrows than Custer's last stand, which is always like a bad sign when you're looking at a pathway, and it just tells you there's a lot of enzymes here and a lot of activities and things that you have to put in. So it's quite complicated genetic engineering already. To try and get from sort of here, this is the vegetable omega-3s, and you have to get them all the way down here to DHA, which is the fish oil omega-3. And if you want to do metabolic engineering, it's not just about finding genes. You have to find genes. You have to put the genes via a gene transferring system. So this is a natural agrobacterium and soil-borne bacteria that will transfer genes into plants. And then you do that, and you'll get your transgenic plants, and then you have to screen them and do lots of analysis. And it's complicated. We have a good setup at Rothamsted to do this, but it takes time. And it's a research project because you're still trying to work out what are the right combinations of genes, what is the best way to try and optimize the accumulation of your fatty acid. And this, I put this slide up, and it's just to sort of almost to remind me that we've got so blasé about doing this, is each one of these little blocks is a different gene that you're putting into your plant. And what's interesting from our, as I say, as we move from a research phase to a development phase, is that you realize that each one of these, for example, has its own, in fact, each one of these elements is probably covered or attempted to be covered by a number of different patents. So from an intellectual property point of view, having freedom to operate to do this is quite complicated. Trying to do freedom to operate analysis in terms of IP on all of these elements is pretty complicated. And you get quite conflicting, depending on how much money you spend on your patent agent, you can get quite conflicting data back on it, because a lot of these patents are still in prosecution, and you haven't got an opinion on really where they're being granted or what territories they cover. So you do this experiment where you sort of like, so this is all the genetic transformation. We have high throughput analysis to allow us to analyze as many plants as we can generate, and you can sort of just, actually we've got to the stage where, although at Rothamsted we have a lot of facilities for growing plants, we've got a lot of transgenic containment glasshouse, but we got to the point where I don't know, we had hundreds and hundreds and hundreds of square meters full of transgenic plants where that becomes the bottleneck of doing the analysis. All this high throughput equipment can analyze pretty quickly. It's growing the plants that turns out to be the sort of the bottleneck. And this is just a sort of, again, this illustrates the sort of high throughput analysis you can do by mass spectrometry to really get to the authenticity of the product that you're trying to make and really be sure that what you've made is what you think it is. And really, this is the sort of nuts and bolts of if you like, 15 years of metabolic engineering in transgenic plants. So this is a camelina seed. And this is the fatty acid profile of a camelina seed, and this is what you would say is bulk fish oil. So this bulk fish oil contains these two fatty acids that people are really interested in, EPA and DHA, at usually a ratio of 1:1 of about 25% of the total oil. And this is a transgenic camelina plant that contains one of these key fatty acids, EPA, and it contains 30% of this particular omega-3. So this is pretty good. But in fact, this one was even better, because this one is, again, comparing bulk fish oil with our transgenic seed, and it's got a mixture of EPA and DHA, the same or even slightly better than bulk fish oil. So after 15 years, I can now retire. Nobody has to listen to me droning on about how maybe next year it'll be successful. This time, we've actually produced, we can make fish oils at the same level as you find in a fish oil in a transgenic plant seed. It's not exactly the same as a fish oil because the fatty acid profile is slightly different in plants from fish oils, but the key ingredients, the ones that do you good, the ones you can't get normally in plant oils, the ones that protect you from cardiovascular disease, we can make in our fish oil, in our transgenic plants. And this is just to show you, they look exactly the same. This is what camelina looks like. It's actually a capsule plant. It has capsules, it doesn't have pods, even though it's a brassicaceae. And these are what our transgenics look like. They look exactly the same. So there's no sort of, they don't smell of fish, in case anybody's worried. You know, they don't, yeah, they just look like normal plants. And that's really, you know, and I think that's where I stop, because it's really, that's where the whole project sort of stops being a research project and has to start being a development project or a commercialization project, and you work out how is this going to get into the food chain. The reason I did this project at an institute is because I wanted to go all the way through from research to development and beyond, to the point where if I spend years banging on to people about how good this is for their health, actually it's important that it gets into the marketplace, and you know, and we can demonstrate that it has efficacy and that it's available and it's useful. So to me it's really important that the research gets translated through into something beyond than just sort of something that stays in the lab. There is no way that I ever want this to stay in the lab. I would like to see it through to move into the field and move into sort of like and ultimately be able to of benefit to the consumer and the end user. So I mean, you know, I've told you where we've got to. I mean, there are things that we need to do. Obviously, we need to show that the oil is stable over a long period. You know, I really would like to carry out a field trial at Rothamsted. You know, we need to get, obviously, depending on statutory approval from DEFRA and their specialist committee, ACRE, that would allow us to see how this performs in the field. You know, and then, you know, and we want to demonstrate that our oil can substitute for fish oil in say, for example, and I think the really pressing need is in aquaculture. So we'd like to do feeding studies in fish feeding studies to show that we can meet the need that the aquaculture has as a replacement for fish oil. So thank you very much for your patience, and if you've got any questions, we're going to do the questions now or later? Now. Okay, thank you very much. Thanks.